All right, so I'm going to go ahead and talk about the graph of tangent and what the period, domain, range, where the vertical asymptotes are, what the zeros are, where they occur, where is this graph increasing and decreasing, and what is actually happening as x approaches pi over 2 from the left and when x is approaching pi over 2 from the right. Well, let's just talk about the graph first and foremost. Tangent is sine over cosine. So the one thing that you always have to caution yourself on when you deal with a fraction is when you get 1 over 0. When you get 1 over 0, that is going to be your vertical asymptotes, as we talked about with the secant and cosecant. What's really nice is that tangent, if you know where cosine equals 0, which you can use the unit circle or the graph of cosine to find the zeros, your actual zeros, your vertical asymptotes for tangent are going to be at pi over 2 and 3 pi over 2. Now when we actually go to graph this, we are going to have an x-intercept at pi, and it's going to increase as it heads towards 3 pi over 2, and it's going to decrease as it's heading towards pi over 2. Now we also have an x-intercept at 0, and it's increasing, and at 2 pi, and it's decreasing. This is actually 2 full periods, because if I would move this graph right here to over here, you would see that it actually lines up. So let's actually answer that question. What is the period of tangent? Now, if you remember, tangent period is how long does it take for it to actually repeat? It takes this long for it to actually repeat, which is actually 3 pi over 2 minus pi over 2, which then gives you 2 pi over 2, which is just simply pi. So the period of tangent is nothing more than pi itself. The domain of, well, let's talk about vertical asymptotes, because that's what we did with secant and cosecant, is we did the vertical asymptotes first. Our vertical asymptotes is when you get 1 over 0. Where does it occur? Well, if you look over here on the graph, my vertical asymptotes are at 1 pi over 2, 3 pi over 2. There's another one at 5 pi over 2 and 7 pi over 2. It still has that pi over 2 in it, but it's the odd numbers. So much like the graphs we were doing before, we have to write an equation for our vertical asymptotes. It's going to be x equals 2k plus 1, 2k plus 1 times pi over 2, such that k is an element of the integers. Well, once we know our vertical asymptotes, we also know the domain, because the domain is going to be the set of all my real numbers except for my asymptotes. So we do x does not equal 2k plus 1 times pi over 2 such that k is an element of the integers. So once you know your asymptotes, you really know what your domain is as well. You just have to remove the asymptotes from all the real numbers. The next thing we want to talk about is the range. Well, the range is your y values. Well, if you come over here and we look at the graph, my y values start way down here at negative infinity, and it keeps going up and up and up all the way up to positive infinity. So my range for my y values is from negative infinity to infinity. And of course, you can never touch infinity, so we use the parentheses and not the square bracket. My zeros, I have an actual infinite amount of zeros. I have a 0 right here at pi. I have a 0 here at 2 pi. I have a 0 here over at 0 pi. We also have a 0 at negative 1 pi, negative 2 pi, also at 3 pi, and at 4 pi. It's actually the multiples, just a basic pi times an integer. So we write that equation. My zeros is going to occur when my x is going to occur k pi such that k is an element of the integers. Ones with tangent and cotangent, we're going to have a lot more equations with integers with k. I want to use k for integers majority of the time. It's pretty standard to use k as integers. All right, so let's talk about increasing and decreasing. Well, in class we talked about having a little man and picturing what he has to do. Well, I have a little man right over here. I just chopped his head off. But I have a little man right here. And I can take this little man, and we're going to start from left to right, and we have to see, what is this little man doing? He actually has to walk all the way up this graph. He never gets a break. He never gets to slide down. Never, ever does he have to slide down. So he's actually increasing everywhere. So he's increasing on all the real numbers. So we can actually say he's increasing from negative infinity to infinity. He's increasing from negative infinity to infinity. Unfortunately, he didn't slide down the graph anywhere. So it doesn't decrease anywhere, so that one's not applicable. Now my last two questions. What is happening when x approaches pi over 2 from the left? What is my f of x value? So let's look. Pi over 2 is right here. Pi over 2 is right here. This line right here. And we got to see what is happening when we're going towards the left. Well, if we start here and we're going left towards it, we're going all the way down to negative infinity. All the way down to negative infinity. Right here. So our answer over here is nothing more than negative infinity. So let's look at this other one. What is happening then? Well, when x is approaching pi over 2 from the right, what is my y value? Well, if I'm coming here and I'm approaching it from the right, it's going all the way up to infinity. It's all going all the way up to infinity. So here, the answer is infinity. So as x is approaching pi over 2 from the right, now keep in mind, guys, remember that this minus right here in the exponent spot, that is actually meaning that it's approaching from the left. The plus means it's approaching from the right. So once you go through, answer these series of questions. I'm not going to do one on cotangent. It's quite similar. We'll do that in class. You'll be able to take notes on it, but this will at least get you started.